Hello everybody, welcome back. Welcome to ACE Engineering Academy and ACE online platform. So today, we are here to discuss about the power systems and in that fault analysis as a course of RRB JE for EEE students. Right. So in this course, we are going to discuss about some important concepts and some important questions in this session. Right, students. So first of all, if you see, the power systems is one of the most important subject. So in every competitive exam for electrical engineering students, if you see the syllabus of power system, the syllabus of power system, it consisting of generation of electrical energy, transmission and distribution of electrical energy, and fault analysis, and switchgear and protection, and along with that, the RRBJE students, we are having utilization of electrical energy also we are having, and along with that, we are having in utilization of electrical energy, we are having estimation and costing also, right? So this is the syllabus of complete power systems students. So we are having huge syllabus for power systems, so that we can expect more number of questions from power systems. So at least we can expect 20 to 25 questions, a minimum of 20 to 25 questions, a minimum I am saying 20 to 25 questions we can expect only from the power systems, right? So in that, first of all, if you see the fault analysis part, today we are going to discuss about the fault analysis. And if you see the fault analysis syllabus, right? So if you want to enter into fault analysis, so if you want to enter into the fault analysis portion students, right? So we have to learn, these are the basics. What are the basics? First of all, understand the basics of the power system network. In basics of the single phase power transmission system as well as basics of balanced three phase power transmission system. Right? Basics of single phase power transmission and basics of three phase power transmission, try to understand that one. Whenever you are understanding balanced three phase power system, then only you can understand the unbalanced three phase system. So in chapter 1, we can understand balanced three phase power system network analysis, right? And later on, we will see the representation of power system network in the per unit form. Representation of power system network in the per unit form. So whenever you are representing the entire calculations in per unit form, the advantage is that the calculation speed will be increased and the quantities will be very, very less, so that we can say the calculations complexity will be reduced, right? And we are having lot of advantages we can see in the detailed discussion of per unit systems. Right? And in the next chapter, the basics of unbalanced power system. In the basics of unbalanced power system students, we have to understand the symmetrical component theory. Here we can understand the symmetrical component theory. Symmetrical component theory. So the symmetrical component theory to analyze the faulted power system network, right? So after understanding the theory of symmetrical components, we have to represent all the power system elements. So the power system elements are what? Generator, transformer, transmission line, and the motors, right? Maybe synchronous motor or the induction motor. We have to represent all the power system networks in the symmetrical networks representation. Clear, right? And finally, after understanding all these things, we can enter into the fault analysis. So without knowing all these concepts, it's not possible to enter into fault analysis. In the syllabus, they have given simply as a fault analysis. But if you want to enter into fault analysis, these are the basics or prerequisites we need to study the fault analysis students. Clear everybody? Right. Now, after knowing the syllabus, what are the textbooks we can prefer? Right? So the textbooks we can take are just here. So the one of the best textbook of power system, we can say the Stevenson and Greiger, power system analysis by Stevenson and Greiger, right? So we can take, this is the Stevenson, William Stevenson and John J. Greiger, we can take for the power system analysis. So in that portion, so we are having transmission, it will be covered, and they are covering the fault analysis, and we can cover the switchgear and protection portion also. Right? So in the syllabus of that one, we can cover transmission and distribution, transmission only, not the distribution, transmission, fault analysis, and switchgear and protection portion in the textbook. Right? And similarly, we are having modern power system analysis also in this textbook. So it is also one of the similar textbook related to the Stevens and Geiger. So we cannot say which is the best book. We can take any one, right? D.P. Kothari and I.J. Nagrath. Modern power system analysis by D.P. Kothari and I.J. Nagrath students. And if you want to practice more number of questions, you can take C.L. Wadhwa and J.B. Gupta. So these textbooks are having some practice questions at the end of the textbook, right? In most of the competitive exams, we are getting the questions from those questions. In most of them, right? So we cannot trust every time, but we have to practice basically. So we have to practice all those questions, right? Now, so after knowing the textbooks, so what we can practice actually? So if you want to get maximum marks in power system, what we can practice? So we can practice the ESC, Engineering Services objective questions related to all concepts, right? So prelims questions only, right? Only the prelims questions, and the previous public sector unit questions, and we can take previous state board questions like Genco, Transco, like that questions, and previous SSC JE and RRB JE questions we need to practice, right? And the question level is not that much very high. We have to practice only little bit of so similar, that is somewhat low level concept, low level questions, right? We cannot expect very high level gate standard questions and very high level. So ESC, in ESC we are having sometimes gate level questions are there. No need to practice that much questions, right? So the level of questions, right, whatever they are asking in RRB JE or particularly SSC JE are somewhat, right, somewhat low, not very low, right, moderate we can say, right? This is the practice set we can maintain, for getting maximum marks, right? So now we'll see somewhat important concepts today in the class. See here. So representation of power system network in the per unit representation or per unit form. See here students, the power system is consisting of several elements: generators, transformers, transmission line and the loads, right? So if you see the single line diagram of the power system, the single line diagram of power system, it consisting of generator and transformer and the transmission line and one more transformer and the motors are the loads we are having here, are the loads. So this is the generator we are having, generator. This is the transformer T1 and this is the transformer T2 and this is the transmission line. So these are the elements. So if you see the transformer is magnetically coupling the circuit but electrically disconnecting the circuit, right? So whenever you see the representation of transformer, so the representation of transformer, it consisting of primary winding as well as the secondary winding, and this transformer, it is electrically isolating the networks and magnetically coupling the network. Because of the presence of this network or transformer, the analysis of this power system network will become difficult. That is the reason we are shifting, that is one of the reason we are shifting into the per unit system representation. And whenever you are shifting into per unit system, the representation of transformer will be very, very easy. We can directly connect a primary winding and the secondary winding in the per unit form representation, Now, so first of all, we'll see what is the basic definition of a per unit quantity. What is the basic definition of a per unit quantity? Per unit value of any quantity. Per unit value of any quantity. The per unit value of any quantity, if you want to calculate, you can calculate. It is the actual value of any quantity in any unit. We can take the actual value of any quantity in any unit divided by the base value of the same quantity in the same unit. Base quantity right, or the base value of the same quantity, base value of the same quantity, base value of the same quantity in same unit, right? Simply we can write this as actual value divided by base value, actual value divided by base value, right? That is the formula to calculate the per unit value, right? Now, suppose if you are having the generator here, we are having the generator, the first element of the power system network. What is the rating of generator we are having? The rating of generator we are having. So, the apparent power rating will be given as well as the voltage rating of the generator is also given. If you see that the rating of a three-phase synchronous generator, the rating of a three-phase synchronous generator, if you take this, they will give the first one they will give, it is three-phase apparent power rating, three-phase apparent power rating. It should be given in MVA. Normally it will be given in MVA, megavolt ampere, and along with this one they will give the line to line full load RMS voltage rating, line to line full load RMS voltage rating, this will be in kilovolts they will give. So, these are the two ratings they will give. What are those? Three-phase apparent power rating, in MVA, and line to line full load RMS voltage rating in kilovolts. So that whatever they have given, you can take those as the base values. Now, you can take this as the base value, S base. The representation of apparent power will be S. And as it is three-phase quantity, we can write as S base three-phase quantity. And the line to line voltage they are giving. So whenever the line to line voltage is given, we can consider that as the base voltage, V base line quantity, Suppose if they are asking in single phase quantities, we can convert these two into single phase also. How to convert those into single phase? Just check here. So if you want to calculate S base single phase, what is S base single phase, students? S base single phase is nothing but S base three phase divided by 3. S base single phase is nothing but S base three phase divided by 3. Now, if the generator is star connected, what is the phase value? The VB phase value. You can calculate the base phase value. The base phase value is magnitude. What is the base phase value magnitude? It will be VB line divided by root 3. Like that, we can calculate S base single phase value and VB phase value. Right? So finally, we got S base and V base, right, in single phase terms. I have taken, it is S base and it is V base. What are these? These two are the single phase quantities. When S base and V base are known, we can calculate I base. What is the formula to calculate I base, students? The formula to calculate I base in single phase terms, what is that? S base single phase value is nothing but VB phase value, that is V base, into IB phase value, what is that? I base. Therefore, we can calculate the I base value. What is I base value? the I base value is equivalent to S base divided by V base. S base divided by V base. Like that you can calculate I base. After calculating I base, we can calculate Z base, impedance base, right? Therefore, we can calculate impedance base. What is that? Z base. Z base. What is Z base? If you want to calculate base impedance, it will be base voltage divided by base current. What is that? VB, V base divided by I base. V base divided by I base. Like that we can calculate Z base, students. Is it clear, everybody? So that finally, how many base quantities we are having? Finally, the base quantities we are having are, if you check here, so finally the available base quantities, are S base, V base, I base, Z base, right? These are the only available base quantities in entire power system network. Other than these, we don't have any base quantities. So we have to use these base quantities for calculating every per unit value in the power system network. What are those? S base, V base, I base, Z base, right? But initially, how many base quantities we know? Initially, we know only two base quantities. What are those? S base, V base, S base and V base. That is S base and V base. It may be three phase or single phase. Now, so if you know two, the remaining two we are going to calculate. That means in these four, at least two quantities are required, right? So when two are known, the remaining quantities we can calculate. Therefore, the condition here it is, these are the only available base quantities. In these, at least two quantities are required. At least two quantities are required. Two quantities are required to calculate the per unit values of all the power system networks. Clear, right? Now after calculating Z base, we can calculate the per unit value of the impedance. So what is the per unit value of impedance? The per unit value of impedance, it will be Z per unit. Z per unit is nothing but Z actual value divided by Z base value. Now tell me, what are the units of Z? The actual units of Z are in ohms. Z base is also in ohms. So ohmic value divided by ohmic value, you will get the per unit value or no unit value. So that per unit value is nothing but it's a no unit value. Now tell me, students, it is Z actual, it is in ohms, divided by, what is Z base? It is V base divided by I base. It is V base divided by I base. V base divided by I base. Now it will be, you can send I base to the numerator, it will be Z in ohms into I base divided by V base. I base divided by V base. And you can multiply this one in the numerator and denominator with V base, right? Just try to multiply this one with V base in the numerator and denominator. It is V base divided by V base. Then what it will be? V base into I base will be S base, and V base into V base will be V base square. Therefore, the per unit value of any quantity, any impedance quantity, Z per unit is nothing but Z in ohms into S base divided by V base square. That is the per unit value of this quantity, students. Clear, right? Like that we can calculate. Like that you can calculate, right? So now, so we'll see. So how many students are responding there? Just have a look here. How many students are responding here? Right, students? So if you are having any doubts, you can send your doubts here. Right. Yeah. So good evening, Amala. Right. Good evening, Mahesh Babu. Right, students? Right. Right. So okay, students. So we'll continue here. So now we have calculated Z per unit, which is equivalent to Z in ohms into S base divided by V base square. V base square. Now sometimes they will change the base quantities. For example, students, in an exam you got 50 marks, and they are saying that your percentage is 50%. You got 50 marks and your percentage is 50%. Then tell me what is the base value they have taken, right? The base value they have taken is 100. So that whenever you got only 50 marks, when that 50 marks, whenever it is calculated on a base of 100, and they are saying that it is 50%. It is 50%. Now tell me, if you are getting only 50 marks, and if that 50 marks, if they have calculated on a base of 200, on a base of 200, I am not calculating on a base of 100 now, I am calculating on a base of 200. When base is changed, what is that? 50 divided by 200, how much it will be? 0.25, that is 25%. 25% means whenever the base quantities are changing, the per unit quantity is also changing. Per unit quantity is also changing. Therefore, so sometimes in some of the questions they will change the base quantities, right? And they will ask what is the new per unit value based on the new base quantities. But remember that even though if you have changed the base quantities, the actual quantity will never change. Why? Because you got only 50 marks, right? And that 50 marks they are calculating based on different base quantities. So that ohmic value will never change. That means a 1 ohm resistor is always a 1 ohm resistor. If you change the supply voltage or if you do anything, that 1 ohm resistor will not become 2 ohms resistor, right? Its per unit value or its percentage value may change, but actual value will never change. Clear, students? Now, therefore, so what happens when the base quantities are changing, right? If you see, I can calculate here. They have given change in base quantities, change in base quantities, change in base quantities. Initially, you are having a per unit value, that is old per unit value. Z per unit old you are having. Z per unit old value you are having. And the actual value of that one is Z in ohms into S base. I will write SB for S base. S base old value, and we are having V base. I will write VB. VB old value square. V base old value square. This is the so old and old base quantities we are having old per unit value. Now they are asking what is Z per unit new value of the same ohmic value on S base new value divided by V base new value. Now check here, when actual value is known, and new base quantities are known, you can directly calculate new per unit value directly based on the new base quantities. So clear, when you are having 50 marks, whenever you are having 50 marks, that 50 marks can be calculated on a base of 100 or on a base of 200, whatever it may be. But sometimes they won't give the marks value. They are saying that you are having a percentage of 50 on a base of 100, then what is your percentage on a base of 200? Like that they will ask the question. Means that they are not giving the actual values, but they are giving the percentage, your percentage on a base of 100, and they will ask you what is your percentage on a base of 200. Like that they will ask. Means they will give old per unit value on a base of these two, S base and V base, and they will ask you what is the new per unit value on a base of S base and V base square. Clear, students? Now we will take the ratio of these two. Take the ratio of these two. The ratio of these two will be Z per unit new divided by Z per unit old. Z per unit new divided by Z per unit old is equivalent to, just check here, Z in ohms and Z in ohms will be cancelled, right? Z in ohms and Z in ohms will be cancelled, and it will be S base new divided by S base old, S base new divided by S base old into V base old will go to the numerator. It is V base old divided by V base new whole square. V base new whole square, right? And what is the finalized formula? You can send Z per unit old to the right hand side. Therefore, what is Z per unit new? Therefore, Z per unit new is equivalent to Z per unit old value into S base new value divided by S base old value into V base old value divided by V base new value whole square. V base new value whole square. So like that you can calculate new per unit value on the new and old base quantities, and whenever old per unit quantity is available. Right, students? Now based on this formula, we will solve one problem here. So try to solve this problem. Just check here. The per unit value, the per unit impedance of a quantity is 0.2 per unit on a base of 100 MVA and 100 kilovolts. Then the per unit impedance of the same quantity on a base of 200 MVA and 200 kilovolts is. So what is that value? Try to calculate this one. The per unit impedance of, this is old per unit value they have given. On a base of 100 MVA, old MVA, and 100 kilovolts is the old voltage. And they are changing that to new MVA, it is 200 MVA, and new kilovolts, it is 200 kilovolts. Then what is the per unit value of the quantity? Now, try to calculate it. Good evening, Anita. Right. Hi everybody. Hi. Will you tell me the answer for this question? Anybody in the class? Will you tell me the answer for this question? Anita, Amala, Mahesh Babu and Anji, Bhavani Prasad, can you tell me the answer? Very simple question, just on the base quantities. So this type of questions we can expect in the RRB JE examinations. So Anita given it is option C, very good. Right, students? Right. Just check here, students. So they have given, just let me solve this one. Just check here the solution. What is S base old value? S base old value is given. How much it is? 100 MVA. V base old value. It is given as 100 kilovolts. And what about Z per unit old value? Z per unit old value is given 0.2 per unit. And S base new value. What is S base new value? It is 200 MVA. And what about V base new value? The V base new value is 200 kilovolts. And they are asking what is Z per unit new. Tell me what is the formula? Z per unit new value, Z per unit new value is equivalent to Z per unit old value, Z per unit old value into S base new value divided by S base old value into V base old value divided by V base new value whole square. V base new value whole square. Right? So that is the formula we are having. Just substitute those values, we will get the answer, right? So that what is this value? This is equivalent to at Z parent old is 0.2 into S base new is 200 MVA and S base old is 100 MVA. So that MVA will be cancelled, and here V base old value, what is V base old value? It is 100 and V base new value it is 200 whole square. 200 whole square. What are the cancellations we can do here? The cancellations are, so 2 zeros will be cancelled here, 2 zeros will be cancelled here, and here it is also 2 zeros will be cancelled. So in the numerator we are having 2, here it is 1 by 2 square. So 1 by 2 square will be 1 by 4. So that 2 and 1 2 will be cancelled. Here it will be 0.2 into 2 by 4. It is 0.2 by 2. It will be 0.1 per unit. 0.1 per unit. So that what is the correct answer here? So the correct answer is 0.1 per unit. Very simple formula based question, students. Just remember the formula, you will get the answer. Just try to remember the formula, you will get the answer. Right? So very simple question, the very basic question in the per unit quantities. Per unit quantities. Right, students? Right. Very good. So most of the students have given here. So Hari Veera Reddy, Upendra Naini, Amala Gracie, very good. Bhavani Prasad, Harinath Reddy. Perfect, students. Perfect. So you have given the answer perfectly. Very good. Now we'll see the next thing here. Just tell me what is the phase sequence of the given system. What is the phase sequence of the given system, students? So A, B and C are given here, and the 4 options are given: ABC, CAB, BCA and CBA, and they are asking what is the phase sequence of the given system. Now tell me how to find the phase sequence. To find the phase sequence of the given system, just let me give you the answer here, right? And most of the students will give the answer. Right? And it is already discussed in some of the previous sessions. Now check here. Suppose if you are having a positive sequence system, in case of the positive sequence system, students, the positive sequence components always having equal magnitudes. So that the magnitude of phase A vector, suppose if this is the phase A vector, A phase, and the magnitude of phase B vector, and the magnitude of phase C vector, will be same, right? So all the 3 are having the equal magnitudes, and the phase angle difference between them will be 120 degrees in the anti-clockwise direction, 120 degrees here and 120 degrees here and 120 degrees here, and these will rotate in the anti-clockwise direction always, and I am saying the phase sequence of this system is ABC, right, whenever they are rotating in the anti-clockwise direction. So that we can say the phase sequence of this one is A, B and C. How to find it is ABC? Just take a person here and assume a person is standing here. And he is looking towards the vectors. Now tell me the vector first which can meet the person. The person is not moving here. Who are meeting? The vectors are meeting. Tell me the first one, the which can meet the person is A phase. After that B can meet the person B phase, and after that C can meet the person C phase. A, B and C. That is the way of finding the phase sequence. Just check here. The person should never rotate. The person has to be stationary there and the vectors will rotate. Vectors will rotate. So that A meets the person and B meets the person and C meets the person. Now tell me, what is the reference phase are here? The reference phase, whatever you have started here. So that as you have started with A, that is the reference phase. That means whenever you are starting with A, that is the reference phase. Suppose if the same person is standing here, and he is looking like this. That means he is looking the next vector. Then tell me, the first vector which can meet him. What is the first vector which can meet him? That is phase B. It's not phase A, it is phase B. So that he can see first of all B. After B, what is the vector it is going to meet? C. After C, A can meet. B, C, A. So that A, B, C is whenever A is started, that means A is the reference vector. The same phase sequence will become BCA when B is the reference phasor. So that here B is the reference phasor. Now, if the same person is standing here, and he is looking in this direction. Then tell me, so what is the first vector which can meet him? C, right? So that he can see phase C first of all, and then A phase, and then B phase. Then what is the reference phasor? The starting one. C is the reference. So that you can say ABC, BCA and CAB all are same. So all are positive sequence only. Just there is a change in the starting point. Therefore, ABC or BCA or CAB all are belongs to the same phase sequence. You can check here in the options. ABC, CAB, BCA all are same only, right? ABC, BCA and CAB all are same. So that you can think the correct answer is option D. But we have to give the clarity why it is option D. Just check here. This is the positive sequence system. Now we'll see what about the negative sequence system. Actually, according to the definition of negative sequence components, the negative sequence components will rotate in opposite direction to that of the positive sequence components. If you see the negative sequence components, students, negative sequence components according to the definition of negative sequence components, these will rotate in opposite direction to that of the positive sequence, right? So you can write here. So these will rotate opposite direction to positive sequence. Now, if positive sequence is ABC, if positive sequence is ABC, then what about negative sequence in reverse order? In reverse order it will be CBA. Then negative sequence will be CBA. And these are rotating in which direction? Opposite direction to that of the positive sequence. So just check here, the positive sequence are rotating in anti-clockwise direction, therefore the negative sequence will rotate in the clockwise direction, right? Therefore we can represent these vectors in the clockwise direction. Now tell me, what is the starting point you are having? The starting point is vector C. This is the C phase vector, and in negative sequence also all the vectors are having equal magnitudes. The magnitudes will be same and the phase angle difference are 120. Now these are rotating in the clockwise direction. So C is rotating in clockwise direction. The person is standing here. The person is standing here and he is seeing in this direction, and what he is getting here? He is getting C phase and then B phase and then A phase. C phase, B phase and then A phase. C we got here, and then B and then B. So B you have to plot in this direction. Why? Because the vectors are rotating in the clockwise direction, and then we can plot A phase here. This is A phase, right? So represent the vectors, they are rotating in the clockwise direction. Clockwise direction. Clear, right? Now the angle from here to here it is plus 120. The angle from here to here it is plus 120. The angle from here to here it is plus 120. Now check here. Previously we have represented the angle in the anti-clockwise direction as plus 120. Now in this direction, now it will be plus 120. But we should not have two different conclusions at a time, right? We need to follow only anti-clockwise rotation or only clockwise rotation, right? So that to maintain anti-clockwise rotation every time, we are going to represent these vectors in the anti-clockwise direction. These vectors in the anti-clockwise direction. And what is the reference? Here we have taken A phase as the reference, so that we will take the same A phase as the reference and we will see what we are going to get here. What is the, whenever A phase is reference, the person is standing here, and he is looking in this direction. So that what is the first vector he can meet? A phase. And what is the second vector he can meet? C phase. And what is the next vector he can meet? B phase. So that ACB he is going to get. ACB he is going to get. So that by fixing ACB, represent these vectors in the anti-clockwise direction. Represent these vectors in the anti-clockwise direction. Just check here. So to maintain the uniformity, we are representing this in the anti-clockwise direction. First of all, I am drawing A phase here. Phase A. Now, in which direction it is going to rotate? Anti-clockwise direction. We are representing this one in the anti-clockwise direction. A phase. So as it is rotating in anti-clockwise direction, the person has to stand here and he has to look in this direction. So that A is meeting him. Then what you have to get? ACB. He is getting which one? He is getting ACB. As A you have plotted here, then we can plot C here. So the next vector he has to meet is C. It will be C, and the next vector it should be B. And all these are rotating in the anti-clockwise direction. Clear, right? Now the angle from A to B is how much? 120. Previously what is the angle from A to B? It is previously 120. The same angle we are maintaining now. So that we are not following this one. So for the standard notation we are following this one. That is the definition, right? And we are shifting that definition to the anti-clockwise rotation. So from A phase to B phase it is 120, right? And B phase to C phase it is 120, and C phase to A phase is also it is 120. When A phase is reference, it is ACB. When B phase is reference, the person is standing here and he is looking in this direction. What he is going to get? BAC. Will get BAC when B phase is reference. The same person he can get CBA, right? So that the same person is looking in this direction, so that he can get first vector is C and then B and then A. So whenever C phase is reference. So that based on the reference. Now tell me, what are these vectors we are having? So whenever A phase is reference, it is ACB. Whenever B phase is reference, it is BAC. And whenever C phase is reference, it is CBA. So all these are same phase. All these are same phase. Right? Now we'll see the question here. What is the question they have given? The question they have given, it is ABC. ABC. It's not ABC. Just check here. So what are the vectors? It is rotating in this direction. It is also rotating in this direction. It is also rotating in this direction. Right? So every time the vectors are rotating in the anti-clockwise direction only. Every time the vectors are rotating in the anti-clockwise direction only. Right? Now, if you start at point A, the person is looking at this direction, A phase, and then C phase, and then B phase. So that it's not ACB. So it is ABC given, so it is ACB we have to get. Suppose if the starting point is B, the person is looking here, then tell me B you can get, and then A, and then you can get C, BAC, right? So but it is given BCA, no. Next, the person is standing here, tell me, he will get C vector first, and then B vector, and then A vector, CBA, so that it is CBA, it's not CAB, CAB. Just study the concept and try to represent them in the phasor diagram, then it will be very easy to identify the phase sequence. No need to by heart anything. Clear, right? So what you have to learn? Concept here. Clear, everybody? So I think it is very clear for you. Very simple. Very simple. Right, students? Right. So now we'll go for the next question here. Yeah. Just check here. The next question. If operator K is equivalent to 1 at an angle of 120 degrees, then the value of K square minus K. If the operator value K is equivalent to 1 at an angle of 120 degrees, then the value of K square minus K is equivalent to. So students, particularly whenever you are entering into the power system, the basics part, we have to learn two operators. One is operator J and one is operator K. Operator J and operator K. If you see operator J, first of all, operator J is a complex parameter, so that is R plus J XL, right? So that is the complex parameter J, right? So that J always rotates the vector anti-clockwise by 90 degrees. So it always rotates a vector. It always rotates a vector anti-clockwise by 90 degrees. It always rotates a vector anti-clockwise by 90 degrees. Now, just try to understand here. If you are having a vector in this direction, suppose its magnitude is, 1 and its angle is 0, As its 0 angle, we are calling it as reference angle. It is the reference vector. Now, whenever you are multiplying this 1 at an angle of 0 with J, this will be rotated anti-clockwise by 90 degrees. Therefore, it will be rotated anti-clockwise by 90 degrees, so that the next position of this vector will be this one. This is J into 1. Now, what is J into 1? J. What is the value of J? It has been shifted anti-clockwise by how much angle? 90 degrees. Therefore, the angle shift is 1 at an angle of 90. And the mathematical value of this one is root of minus 1. That is operator J for you. And similarly, they are asking operator K. What is operator K? The operator K, it always rotates a vector anti-clockwise by 120 degrees. Operator K always rotates a vector anti-clockwise by 120 degrees. If you see operator K, or some textbooks will give it as alpha, or some textbooks will give it as A, right? whatever it may be the name, definition is same only, right? So that it always rotates a vector, it always rotates a vector, anti-clockwise by 120 degrees. It always rotates a vector anti-clockwise by 120 degrees. Now if you see, if you are having a vector of reference 1 at an angle of 0, this is 1 at an angle of 0, which we can call it as the reference. Now they are asking that operator k, whenever you are multiplying this 1 with k, it will be shifted anti-clockwise by 120 degrees. So that the next position of this one, here it is 90. Whenever you are multiplying with j, it is shifted by 90. But whenever you are multiplying with k, it will be shifted by 120 in the anti-clockwise direction, right? So this will be the k into 1, which is nothing but k. What is the angle shift we are having? 120 degrees. Therefore, the value of k is nothing but 1 at an angle of 120. The value of k is nothing but 1 at an angle of 120. Now tell me, whenever you are multiplying this k with one more k, it will be shifted from here to 120 in the anti-clockwise direction. Suppose if you are multiplying this k with one more k, that will become k square. This will become k square, and the angle shift from here to here it is 120. And what is the total angle shift from the reference? From the reference it is having an angle of 240. Now we are having 1k square. Just check here. What is the question they have given? They have given if k is 1 at an angle of 120. Then what is the value of k square minus k? What is the value of k square, students? What is the angle shift from reference? The angle shift from the reference it is 240. It is 1 at an angle of 240 in the anti-clockwise direction. The same value you can write in the clockwise direction. In the clockwise direction it will be minus 120. This will be 1 at an angle of minus 120. Right? Now take the same phasor diagram. Try to calculate the value of k square minus k. Just check here, students. I will try to calculate here. So they are asking the value of k square minus k. What is k square? You can calculate this one by using your calculator whenever calculator is available. What is the value of k square? 1 at an angle of minus 120 minus k is 1 at an angle of plus 120. When k square and k, that is whenever calculator is available, you can calculate, you can convert that rectangular polar form into rectangular form. We can also convert this polar form into the rectangular form, and finally you can calculate the value, right? You have to do the procedure, we can do it. Now without doing that calculation, we can draw the phasor diagram. What is the phasor diagram? The phasor diagram we are having is, here we are having 1 at an angle of 0. What is this one? Reference. Clear, right? Right. And we can plot k in the anti-clockwise direction. This is k, 1 at an angle of 120. And we can plot k square here. This is the value of k square. And they are asking k square minus k. You are having plus k. Try to solve it for minus k. What is minus k we are having? The minus k you can plot in the opposite direction. Right? So first of all, you can write the angles to get more clarity here. What is the angle from here to here? It will be in the anti-clockwise direction, it is minus 120. So that exact midpoint, we are going to get this one. This is the exact midpoint phasor. So that will divide 120 into 60 and 60. Here it is 60 and here it is also 60. This is minus k. The resultant of k square and k, will be the K square minus K value. Just try to calculate it. Take the parallelogram of this one, right. This is the parallel of this one, and take the parallel of this one, right. So the total angle is 60 here to here, and we are getting a vector, the resultant vector, which is dividing 2 into exactly 30 and 30. This is K square minus K value, K square minus K value. Then what is this angle? Minus 30. What is this angle? Minus 60. What is the total angle from the reference? Minus 90. The total angle from the reference is minus 90. Minus 90. Clear, right? Now, what is the magnitude of this K square minus K? What is the magnitude of K square minus K? You will get it as root 3. Root 3. Let me calculate that. Let me calculate that. What is the value of K square minus K? Try to calculate that K square minus K value. Magnitude. So, the magnitude of K square minus K will be from the parallelogram law. So, it will be under root of magnitude of K square. How much it is? 1. 1 square. What is the magnitude of minus K? It is 1 at an angle of minus 120. You can write it as 1 square. And 2 times of magnitude of K and minus K, 1 and 1. And cos of angle between K square and minus K, how much it is? 60 or minus 60. Both are same only. Cos of minus theta is cos theta. If you take this one, it has 1 plus 1 plus 2 into cos 60 is 1 by 2. It is root 3. So that the magnitude of K square minus K is what? Root 3. Therefore, I can write here. Therefore, K square minus K value is, magnitude is root 3 and the angle from the reference is how much? Minus 90. Root 3 at an angle of minus 90. Very, very easy question. Try to practice the phasor diagram or try to convert polar forms into the rectangular form. But whenever you are solving that one, so at some portion, at some part, you are unable to calculate the magnitude from the rectangular to the polar. Why? Because, so whenever you are having rectangular form, to calculate polar magnitude, square root of real part square plus the imaginary parts you have to take, and tan inverse of imaginary part divided by real part you have to take. Those values may not be known sometimes. But in phasor diagram, we will get the perfect values and they are very simple to calculate. Right? So just see the calculation what I have done here. Yes. So students has given here. So Uma given it is option B. Very good. Very good. The solution is more clear for you, I think. So just go through the solution what I have discussed here. So this is the solution and the question is having a solution of what is that? Root 3 at an angle of minus 90. Root 3 at an angle of minus 90. Clear, students? Now, just check here. We can go for the next concept, that is the fault analysis. That is the fault analysis. In case of the fault analysis, what are the types of faults we are having? The types of faults we are having initially are the open circuit faults and the short circuit faults. The two types of the faults we are having are open circuit faults and the short circuit faults. So types of faults we are having are, first one is open circuit faults, and second one is short circuit faults. In open circuit faults, we are having two types of faults. One is one conductor open fault, and the other one is two conductors open fault. So if three conductors are open, you cannot call it as a fault. That will be a no load condition. So we are having only one conductor open fault and the two conductors open fault. And the second type of the fault we are having is short circuit faults. short circuit faults. The short circuit faults are also called as the shunt faults. Open circuit faults are also called as the series faults. In short circuit faults, we are having single line to ground fault, that is LG fault you can write, that is LG fault, single line to ground fault, and double line fault, line to line fault, and double line to ground fault LLG, and triple L fault, that is triple line fault or three phase fault, and triple line to ground faults. So these are the faults we are having normally. And in this LG, LL and LLG are called as unbalanced faults. The system will become unbalanced there, and or we can call them as unsymmetrical faults. These are unsymmetrical or unbalanced faults. Unsymmetrical or unbalanced faults. And whereas the triple L and triple LG faults, as all the three phases are involved in the fault, we can call them as balanced faults or symmetrical faults. These two are balanced faults or symmetrical faults. Symmetrical faults. In these faults, highest probability fault is LG, the most common fault, and the least common faults are triple L or triple LG faults. That is, symmetrical faults are the least common faults, and the most common fault is LG fault. Clear, right? And the most severe faults are the symmetrical faults, and the least severe fault is LG fault. Right? This is the basic discussion we are having in the fault analysis, and we need to discuss a lot, right, to understand the concepts of the fault analysis, students. Right? So we have seen some questions and we have seen some concepts here. I thought, so yeah, you have understood some concepts here, right? So we need to discuss a lot in the fault analysis. Right, students? So thank you everybody, and thank you for responding everybody, right? Yes, open circuit and short circuit faults. You cannot see me, right? Right, students? So these are the concepts we have discussed today, and some of the questions we have discussed finally, right, students? So thank you for attending the class, and thank you for responding everybody. So that's all for today's session. So we'll meet in the next session, right? Thank you.